Hello, everyone. Hope everyone is having a good day. Let's continue our talk about acids and bases. So we talked about the fact that if you have a Arrhenius acid plus an Arrhenius base, you're always going to be making water plus some sort of ionic compound salt. So for example, if we have HCl acid plus KOH base, we're going to get KCl plus H2O, right? So we call this a neutralization reaction. So an acid-base reaction is a neutralization reaction, which is a chemical reaction where acid and base neutralize each other. Right? But if I had 2 moles of acid and we added that to 1 mole of base, we know that's not going to be neutral. So not only do we add acids and bases, but we have to add the same amount of moles. So what we're going to talk about today is how to, and it's kind of a review, determine moles of a solute. So we remember the molarity formula. Molarity equals moles of solute over liters of solution. It's important to remember that that's liters. So let's do an example problem. Let's say I had a beaker. Which has 2.5 liters of a 0.32 molar HCl solution. How many moles of acid, or H plus, are in the beaker? We know that 1 mole of H plus comes for every 1 mole of HCl. So we can just simply set this up. 0.32 molar equals X moles over 2.5 liters. We do cross multiplication. So we're going to multiply 2.5 by 0.32, and we will have 0.8 moles of H plus. Not too hard. Let's try another problem. What volume of a 1.3 molar NaOH will have exactly 0.73 moles a base of OH minus? So let's set this up again. 1.3 molar equals 0.73 moles over X liters. We got to do a little algebra. So we'll have X liters equals 0.73 moles over 1.3 molar. X equals 0.56 liters of NaOH. So they got, right? Now, for a mixture to be pH neutral, right? Regardless of the volume, of total volume, the moles of acid have to equal the moles of base. If you have too much acid, it's an acidic solution. You have too much base, it's a basic solution, right? We just saw that to find moles of acid from any solution, we do molarity times volume. So what I'm going to do now is I'm going to plug in this equation into here. So instead of moles of acid equaling moles of base, what I'm going to say is that the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And this is our special pH neutralization equation. This will be able to calculate, this will help us calculate how much volume or what molarity we need for each of these substances to make it neutral. Cool equation, right? Let's apply it. So, what volume of a 2.3 molar HCl will be needed to neutralize 35 milliliters of a 0.5 molar NaOH. So the first thing we have to remember is that volume is in liters. So we have to convert that. 35 milliliters equals 0.035 liters. And then I'm going to plug in my equation. So I know my volume of acid. I'm looking for volume of acid. I know my molarity of acid. So molarity of acid, we know volume of acid is X. We know the molarity of the base and the volume of the base. Pluggy chuggy. We got 2.3 molar times VA equals 0.5 molar times 0.035 liters. VA equals 0.0076 liters of NaOH. So we would need 0.0076 liters of NaOH to neutralize that. Let's try another question. What if I told you it took 227 milliliters of HCl to neutralize 250 milliliters of a 1.7 molar KOH solution. Let's determine the molarity of the acid. So same equation, except this time we have the unknown as the molarity of the acid. That times 227, oh, nope, that would be 0.227 liters equals, because you got to convert that, equals 1.7 molar base times 0.250 liters. All right, you do the math. Ma equals 1.87 molar. So that's how we do that, okay? And that is how we calculate volumes or molarities of an acid or a base to figure out how to neutralize. Thank you so much for watching. See you in class. Bye.